So, like I said, welcome to the AI track. This is room 5L. It's been a great day so far. I think we're coming to the end of the day. It's been a long day for everyone. As I said, Alzara Stevens, AI chairman. Today we have Michael Hotovic, who's going to be presenting from Broadcom. I will allow him to formally introduce himself. One thing I will add, please leave your session feedback. That can be done through the QR code at the end and found on our website. And also, if there are any questions, please can you leave them to the end, and we're sure to get them all sorted. So I'm going to hand you guys over to Michael, and I hope you guys really enjoy the session, as I will. Thank you.
Thank you. Greetings, everyone. I would like to welcome you to a session about utilizing generative AI to query database with sensitive data. My name is Michal Hotovec. I've been a software engineer at Broadcom for around 8 years. And mostly I've been focused on workload automation, but in recent years I've been trying to refocus my area into bit into AI ops. So here are some references for those interested to check them out, which I sourced from in this session. And now, as for the session agenda, so first we are going to look into what we are actually trying to achieve with the querying the database with AI, about selecting the appropriate approach. Then we're going to look into using the text to SQL, and there's some we're going to look into some challenges that come with trying to query the database with the sensitive data. So first, what is our goal? Yeah, so we have a database, and we want a user to extract some information from it. And what generative AI, large language models, allow us to do is to ask questions in natural language, so that the user actually doesn't need to know the particular SQL syntax for querying particular SQL database. And also it allows for a certain level of user self-service, because whenever you want a user to ask for some new type of query, in the usual application, you have to implement new API or UI for user to be able to actually send such queries. And utilizing the natural language questions, it actually allows us to take more general approach to this. So first, how we would go about selecting the approach. So the very simple direct approach is you just have the question that was asked by user, and together with the data from database, you feed it directly to machine learning model or some generative AI's API, and you would get the answer. Although this approach is quite simple, there's an issue that you would run into, because the AI has access to all the data, and this actually may raise some concerns, whether business, legal, or ethical, because you might be feeding sensitive data to database in case your database contains some. Yeah, for example, there are like plenty of regulations regarding using personal data, so you cannot then feed such data simply directly to the AI. One of the possibilities how to avoid this is to use some models that you can run locally. One of such models is table question answering, which works in the direct approach, as I mentioned. So you feed a natural question in natural language into it, and benefit of these, they are quite easy to set up to be able to run in-house and locally. And there are various models available. For example, Google Tapas or Microsoft Tapex. And these simply take the question and the data, and then after processing, they generate the answer. Though these models also have certain drawbacks. Yeah, the main drawback that when we were trying to implement this was that these models are limited because of how they sequence the data from database by the amount of the data, total data in the database. So the more, specifically the table cells. Yeah, so the more columns or more rows you have in the database, the more likely are you to run into this limit. And there are ways to increase the limit, but it's actually at the cost of increasing complexity of these models. So they do not scale well to be used for very large databases. So what we need is an alternate approach which would scale better with this database size and would still let us to have some isolation with regards to the sensitive data, so that we don't provide the data to third parties. And one of such approaches is text to SQL. If we use the text to SQL, what we would do is we just take the user's question and put that question to the large language model through some API, or if you are able to run it locally into your in-house model. And this AI would then generate for us a query, which would then we pass into database engine, and we would get the result, which we would then provide user as the answer. Benefit of this approach is it creates an isolation layer between the data and the AI, because you're not actually need to for generating the query, you don't need to provide the database any of the actual data that you have. What's enough is to provide a description of the schema, and the type of data that's in the database, but you don't need to provide an actual data. So if you choose the approach, we have various large language models to choose. For example, you could use some that provide external APIs, so you can remotely connect to ChatGPT 3.5 or 4.0. Both of these versions work just fine. Or alternatively, you can have something that you can run in-house. And one of such models is, for example, SQL Coder, which is developed by DFOG. But there are various other models. One of the good resources to check out is huggingface.co, which is a platform that for advancing AI. It provides various models and data sets for which are good for experimenting, prototyping. They're a very good resource for research. Once we have some large language modules selected, then we need to transform the question that we got from the user into a prompt. The good structure to use is to first specify a role, then describe the context of the query, which in our case would be describing the type of database, the structure of the tables, then the data in the database, just as description, and then we would describe the relationships between the tables, and at the end we just append the question, and we concatenate everything to simple prompt, feed it to AI, and we would get the desired query back. This structure of specifying first role, context, and then asking the question is actually not useful just for the text-to-SQL application, but is generally good for if you try to want to make some large language model to solve some particular problem. So now let's look more deeply onto creating the prompt. So for specifying the role, it's really straightforward since the AI is going to operate on top of some database. So we ask it, act as if you're a data analyst. For describing the context, well, let's say we have an example with relatively simple database. We have just two tables, one with region offices that contains some address of an office, and then another table with data of employees, name, their salary, their roles, and there's one too many relationship between those two tables where some office employs some employee. So to describe this to the AI, we would first specify the type of database. So let's say we have a SQL database. So we tell it we have SQL database with following tables, and then we start describing the table structure and data. So first for the one of the tables, we say we have a table named regional office with following schema, and then you follow it with a list of columns with their types. And afterwards, you just provide for each of the columns detailed description of well, that doesn't have to be particularly detailed, but it's better if it's detailed for the AI to understand better. Basically, the description of what each of the columns, what type of data it contains, and what's the meaning behind it. It actually doesn't have to be the specific syntax that we follow. We just need to make AI to understand. So it actually even works if you, instead of just listing the columns, you provide that the table has been generated with particular command and provide the command that was used to generate the table. But what I'm showing here is one of the approaches that worked for us. Then we continue and we repeat this, the description of the listing and description of the columns for every table that we have in the database. And once we do that, we just describe the relationships between tables. And so in here, we just describe that the region office and employee tables can be joined by column region ID. And once we have the context described, we just ask the question at the end. So we ask, given the database that we described above, create a query that will answer the following question. And then we just provide the question that was asked by the user. So for example, we would have a user ask how many employees work in Washington regional office. And once we feed it to the AI with the prompt, we would get some query like this. It usually there are certain differences based on which models you are using, but generally you would get something like this. Yeah, so we want it by Washington, so it would be filtered by Washington. It would be join of the office and employee tables, and the result would be account. So with this, we sort of have a pipeline for transferring question into query, and then we would get we would execute this query, get the result, and show the result to the user. Though even this approach has some of its own challenges. So one of the challenges is type of challenges are related to the query that comes out of the AI. Yeah, so there's a question of whether the query is valid. Then there might be security concerns with regards to executing the particular query. And then there's also the question of sensitivity of the question itself. So if we look at it in more detail, we need to secure and validate the query. So we should verify that the query is a valid one. And also, one thing to point out is we don't actually have a control about what the AI gives us. So just like we would do with validation of user input in normal applications, we need to do some security validation with the output we get from the AI. Yes, so we would like validate if the query is executed on only the tables or columns we can actually access. And actually, the good idea is to restrict the queries to be read only. Yeah, so we open the connection to the database to be read only to avoid some execution of some queries that might change the state of the database. Yeah, simple, straightforward example is that the user can simply ask a question, how would I delete all data and drop tables in the database? Well, if we would take this question and feed it through our pipeline, we would actually get a query, delete everything from employees, from region offices, and then drop the tables. So this is a type of query that we would probably want to avoid executing. So that's why there needs to be some security verifications and limits when it comes to executing the query. Then there's a question: what if the question itself contains sensitive data? This usually is not a concern if you have a model that can run in-house, but it can be a concern if you are using external third-party API. For example, you're remotely connecting to ChatGPT. So, for example, if we have a question, who are secret agents? The answer we get back from our applications is it's Tim, Jane, and Mike. So far, it's not an issue because AI doesn't actually have access to the answer, just a question. But then a user can ask a follow-up question and simply ask, so what is the salary of secret agent Tim? Well, now we forwarded some sensitive information to the AI, which told us we told it that Tim is a secret agent. So how would we go about this? One way to resolve this is to start masking the sensitive data. So when we receive the question, instead of feeding it directly to the language model, we would instead use some substitute engine which would identify potentially sensitive data in the question, then try to substitute them with some reasonable substitutions, and then out of it we get the masked question that we would feed to the large language model, and that would output a query, but that query would be containing probably some of the masked data points. So then the substitution engine would have to reverse the substitution to for the query to contain the appropriate data points. So when it comes to the substitution engine, there's a problem that needs to be solved: how to identify sensitive data points in the question. So there are various approaches that can be used. One is to have simple rule-based approach. Then there's possible to use database to validate. So you would determine in advance which particular parts of the database contain sensitive data, and you would check if the question contains some of those data points that are in there. And another thing that can be utilized is to do sentence parsing using some machine learning models. So more in details when it comes to rule-based substitution, it's really easy to identify numbers. So you can just identify a number and replace them with some random or some predefined one. Then you can have some columns can contain only specific list of values, so it can be an enumeration. So for that, you could look for the specific enumerations and then replace them. And then there's you could just use usual regex matching to look for specific patterns in the text. So for example, if your IDs have specific format, for example, 2 digits and then 4 letters, you would have a identifier such as this in the question, 15 dash and XRCC. You could then just use regex to identify this, and then you would just select some identifier from predefined list. Then there's a possibility of do the database validation. So first you would in advance identify the sensitive columns which the substitution engine would be checking, and and then when you have the question, then the substitution engine would check if particular words in the sentence do not correspond to some sensitive data point in the database. Though this can actually result in quite a lot of queries. So it's good to combine it with the other approaches to sort of minimize the number of queries that you would potentially be executing. Then there's for the identification, you can also use sentence parsing with some machine learning models. So you could use machine learning to identify each word in the sentence, classify them into categories, and then determine the mapping that each category may correspond to a specific sensitive data columns, and continue with the substitution forward from there. And when it comes to classifying words, there are various approaches. One of these simpler ones is to use part of speech categorization, which can identify nouns, verbs, adjectives, pronouns, etc. And with this, you can relatively easily rule out some of the words that you definitely wouldn't use. Then there's possibility of use machine learning models for named entity recognition. For example, you could have a model that can recognize that particular word or part of sentence corresponds to a specific location, and you happen to have a database model. I mean, a database column in the database that contains specifically names of locations. So you could do matching like this, and then you can also just utilize machine learning models to identify keywords, and you can then match these keywords, for example, using the database validation approach that I mentioned before. Once you have the words or part of sentences categorized, you just substitute them with mark values. So for the substitution engine, you would have defined that for each of these potentially sensitive columns in the database, you have particular list of substitution values. So for salary, it would be list of numbers. For role, it would be some roles you probably are not using in your company, and for names, you will just use some list of random names that are not in your database. So now let's walk through example step by step. So let's have a flowing database with just one table. For the sake of this example, we have it's containing some employee data, and let's say the name, salary, and role are sensitive data, and the user asks questions. Who is an official who has a salary over 5,000 and is not named Lex? So the process of this is that we would fit this into the substitution engine, and it would analyze the sentence. And since the roles are enumeration of possible roles that are in the company, it easily recognizes the pattern. So it knows that this is potentially sensitive. Then it recognizes numbers, so that is potentially sensitive. And then through machine learning, it identified other potential keywords like salary and Lex. And from these, it found out that Lex is actually present in a database in the sensitive column. So it's also considered sensitive. So after that, it moves forward. So the officially sensitive, it replaces with different role, the number with different number, and the name Lex with some different names from the list. So the original question, who is an official who has salary over 5,000 and is not named Lex? You get a must question, who is a cook who has a salary over 10,000 and is not named John Doe? So from this, it would generate a prompt for the AI. Again, assume the role of data analyst. Then there will be the description of the database structure. And then at the end, the must question would be fed to the model. And what the model would output is a database query, but it contains the must values. Yeah? So we see Cook, 10,000, and John Doe, and so the substitution engine needs to reverse the mapping, and it replaces the value with the original ones. So now we have a valid query, which we then, of course, do some validation on it. It would check if it's a valid select, and check if it accesses only appropriate columns and tables which the user has potentially access to read from. And then this query would be fed to the database, and it would give us the result. This particular case, it would be Rose, since she's an official, so over about 5,000, and is not named Lex. So this is a pipeline that can be used in case you have a sensitive data in the base, and potentially there could be sensitive questions, and you're using some API for the AI that you wouldn't be allowed to feed sensitive data to. Though even with this, there are still some challenges that need to actually be taken into account. So one of these challenges are typos, or misspellings. For example, if I would be in the database and you would be looking for Michael, you would actually the database when we would do the matching for sensitive values in the database, we actually wouldn't find Michael, because my name is actually spelled without the E. However, this is still potentially sensitive, and there's so this is a challenge if you try doing exact matching. So this is a problem that you might miss. The another issue is how the AI itself is approaching the typos. So, for example, AI, it's the problem of autocorrect, because if you ever use the chatbot, or at least some of those newer ones, you know that they can understand you if you make typos. Yeah, so what can happen is that AI can assume something is a typo and autocorrects it in order to understand it better, and it actually wasn't a typo. So this actually happens quite a lot with some abbreviations or acronyms that are close to some frameworks. So this is one thing to look out for. And another thing about AI is the AI can actually make typos itself. For example, when we were implementing this approach, we were trying to have user ask questions about topology of our mainframe. So we had a database structure that contained data about our mainframe topology. And there was a column called KICS region or CICS region. And one of the models kept consistently changing it into CCOS region instead. So this is one thing that should be looked out for when you're experimenting with various models. In our case, this was we actually solved it simply by using slightly bigger model, slightly bigger model, and that one actually wasn't making this mistake anymore. What also helps with these two issues on the AI end is if it's some model that you can fine tune, that you fine tune it to your specific database structure. And another challenge that is hard to solve is ambiguity. So you can have certain ambiguities in database schema. For example, you can have in different tables, you can have columns that have identical names or are holding very similar data. And that makes it challenging for the AI to actually tell them apart. So what helps with this is if you actually alter or more thoroughly describe the context of the database when you're generating a prompt. Yeah, so this is one of the mitigation that can be done to sort of make more accurate descriptions of the particular data in database. And then there's the problem with ambiguity questions. And this is something that cannot be really addressed directly because it is a feature of a human language that sometimes the language is ambiguous. So to address this, one of the things that can be done is to provide users additional context when they get the response. Because if the response is just some number, the user actually has no way to figure out that it's incorrect. So it might be, if possible, you can provide the user, for example, the generated query or the columns, list of columns and tables that were actually queried, so that the user can tell that maybe they got an answer to question in a way they didn't mean to. And with this, I would like to thank you for your attention. And I believe we now have time for some questions. And in the meantime, I would also like to ask you to provide a feedback. So you can do it either the link here or use the QR code. And the session is 5L.
Okay, brilliant. Please feel free to drop your questions in the chat. and we can read them out. I'll allow you guys a few minutes to gather your thoughts if you have any on this, or it must have been a very insightful session. Thank you so much, Michael, for that. Michael, I believe there was no questions. I think you did a really amazing job. Thank you so much for your presentation. It was brilliant. Very
Thank
insightful.
you.
Thank you so much. Well, everyone, thank you for attending this session. And I hope that was very insightful for you all. Like Michael said, please do the session feedback when you have a chance. And yes, Michael, thank you so much. And I hope to have you again on the AI track. And I hope you guys have a lovely rest of your day and hopefully see you guys tomorrow.
Great. Thank you.
Thank you so
Take
much,
care,
Michael.
everyone.
Okay, thank you, guys. Bye.